Hey guys, today we're going to talk about arc length, and in order to do that we need a nice circle. There's our circle. So let's say we have a nice arc right here, and if we're trying to find the arc length, what we're trying to find is like the distance between the 2 points that make your arc. So let's say we have A and B. So let's say we're trying to find the arc length of this. We're trying to find the distance from A to B on that arc, and we'll call it the distance L. Now some things you want to point out here. Call this C. From C to B, that's a radius. From C to A, it's also a radius. And this here we said was the central angle. We'll call that theta. So if we're trying to find this length along the arc over here, we can really think of it like in terms of a proportion. The distance from A to B along this arc, so we'll say that was L, that in comparison to going all the way around, which is your circumference, and we might remember circumference is equal to 2 pi r, and we're going to use 2 pi r for this. You're going to see why. So the distance just of this arc, that ratio of that to one whole like lap around the circle, it's in the same proportion of the central angle here, theta, in ratio to going all the way around, which we know is 360 degrees. So this proportion will help us calculate the arc length of any given arc. Now we're going to use 2 pi r because if you have a central angle, you have both a radius, but you could convert it to diameter and just use pi times diameter, but I'll stick with 2 pi r here. Now if you wanted to isolate, you could isolate and just get the arc length by itself. L is equal to, we have theta over 360 times 2 pi r, and you could even simplify further if you want to, and say, well, the 2 and 360 cancel, 180, and we're going to have pi r times our theta, multiplying all these together. Keep in mind this is going to be measured in degrees. I like to use the proportion personally, so let's go to a little problem with this. We're going to be given a circle, and we'll be given some information about it, and we have to find some measurements for an arc length. So let's say this is our circle, and if you're following along in the book, this is page 709. We have this circle here, circle X, and we're trying to find the arc length of YZ, of that arc. We know the radius is 4 inches, and we know the theta down here, the central angle, is 75 degrees. So if we use that proportion, the length over the circumference, 2 pi r, is equal to the central angle over the 360. They're in the same ratio here. Then we can substitute in and calculate what we know. So our length is what we don't know, so we have L. We have 2 times the radius, so we're going to have 8 pi down here. Our angle is 75 over 360. So we can go ahead and multiply both sides by 8 pi. We're going to end up with an answer as a decimal here. We'll round to the nearest tenth over 360. So when we do a little calculating, and we'll use pi as 3.14. Actually, we have a pi button. We'll use the pi button. So when we calculate and divide by our 360, we end up with an arc length of we'll go to the nearest tenth, 5.2 inches here. So that means going from Z to Y, like that arc right here, is 5.2 inches, and we're all done. So I'll give you some examples of these to try on your own. This is how we can calculate the arc length.